Okay, everyone, I'm going to get started to be able to finish chapter 7. So I graded your exam 3, and most of you basically, each of you that took the exam, now you should be able to see your exam 3 grades. So the average was 66, and it was much lower than what I expected because I gave you a study guide, I posted extra lectures and problems for you. So what I'm suspecting is happening is that most of you that don't get good grades, they don't study after each class. So I expect you to whether come to the class, listen to the lectures, and or watch the videos at home if for whatever reason you cannot make it to the class. And as well as that, each time when I teach you something, you should go back home, study those. So as a rule of thumb, on average, after each lecture, you should devote 2 hours to study after the class. And you have like 3 classes per week, so it would be like 6 hours per week. Because if you just want to study like the week of the exam, you have like several exams, right? Several classes. And then if you just want to study chemistry in one night or 2 nights, it's not possible. I'm trying to do what I can to make you all get an A or B. Or at least, get a C or pass the course. So you should kind of like, cooperate with me and then do the things that I asked you to do so that we can accomplish that together. I want all of you to learn and all of you to get good grades. When I, grade the exams and I see that some people didn't do well, it just makes me upset, So just work with me. And to encourage you to come to the class, listen to the lectures, and go study the lectures each time, after each class, I'm gonna assign extra points. So again, like the other, 5 points that I devoted and I gave you, I'm going, the grades that I posted though does not include that, but I'm going to add those. So if you don't listen to me, you don't lose anything. But if you listen to me, not only you learn the course, but also you get extra credits and you can improve your grades of exam 3. So each time, and I'm going to make an announcement about this in BB Learn 2, but don't tell me, that you didn't know about this. I have like people from time to time, they say that, oh, we didn't know that we should give you our solutions as well. If you have questions, just ask me, okay? So I'm going to make an announcement about this on BB Learn 2, and what I'm going to do is that each session, when I'm teaching you things, I'm going to assign some questions, 1, 2, 3, 4, depending on the lecture. And all of those are from the book. And if you listen to the lecture, I encourage you first, you try to solve them yourself. But if you couldn't, just refer to your book. The solutions are there. That is to encourage you to study each session. And each of these questions that I give you in each session are due at the beginning of the next class. Because I expect you to study the course that I'm teaching you today, so on Wednesday, you learn the upcoming lecture. Because now, if you don't know the things that previously I taught about chemical reactions, you cannot understand what I'm telling you now well. And if you cannot do that for whatever reason, you're in a conference, you're sick, you missed a deadline, just email me and ask for extra time, and that is fine with me. But if I don't hear from you, I assume that you didn't care. And I, kind of should get assurance that you care, but you couldn't make the deadline. So, do you have any question about this? Yes? I'm not going to post. I'm going to write it in the lecture. So you see now in the board that, okay, you have like, I asked you to write this chemical reaction. So you're going to see it, here. But I'm not going to post it on Blackboard.
Okay.
Yeah.
But that will all push our exam 3 score?
Yes.
Okay.
Yes.
What do you turn it in?
You can just like, solve it in a piece of paper, take a picture, just email it to me. Any other questions? You can also, hand it in, just email it to me. No, yeah. I just wanted to say, just bring your solutions. So yeah, don't do that. Just email me. Yeah, that would be like waste of so much paper. Any other questions? So these questions that I write down here, just solve in a piece of paper or like in your notebook, wherever. I just want you to learn. Take a picture, email that to me. Very good on this? Yes.
Are you planning on prorating the exam scores? We know they have no.
No, I'm not.
You're not.
And this is the opportunity for you to increase your grades. Because if I give you 4 questions this session that are due next session, I'm going to give you 4 points for your exam 3. And the reason that I'm doing exam 3 is that I'm not happy with the exam 3 results. And overall, I'm going to add that, so it doesn't matter which exam I add that, yes.
So are these questions going to be at the beginning of every class period?
It's not beginning. As I'm teaching you, I give an example about a combustion reaction, for instance, and I tell you that, now you write a combustion equation for burning like methane, for instance. So you see, when you listen to the lecture, I'm telling you that, okay, this is question 1 that I expect you to answer.
So with that, is there going to be extra credit every class period till the end?
Yes, yes. Because I want you guys to listen to each session, and if you do that, basically you can get 100 on your exam 3. Yes.
And then you once mentioned if we did like considerably better on this exam, would you still be replacing exam 2 score or changing it at all?
So what is the question?
Like if you got 20 points more than the last time.
No. So the exam that the grade that I substitute is the exam 3 that you see on your blackboard plus 5 points. That is the one that I substitute for your lowest grade. But these extra credits that I'm giving you now will be added to your exam 3 only. Yes?
So you're not grading averaging the exam?
What do you mean? I already averaged the exam. What do you mean?
Curving.
So I'm not curving it, but this is basically adding grades to you. So it would be even better than curving, I feel like. So if you just work with me, come to the class or listen to the lecture, study, and then do the problems that I'm telling you, and you see the improvement, I hope. Any other questions? So the questions that I'm going to pose during the lecture are related to the lecture that I'm teaching you. So answer them in a piece of paper, take a picture, email those to me. And they are due at the beginning of the next class. And if you cannot do it for whatever reason, just email me and let me know, and I give you extension. But otherwise, I won't do that. Very good on this? And then the amount of points that I'm going to add would be equal to I guess I'll tell you. But I guess I'll make it to the point that it's like 1 for each question. But if otherwise, I'll let you know. Very good? Okay. Now I'm going to continue with precipitation reactions. So anyone remember what was a precipitation reaction? So we have like 2 aqueous solutions, we add them together, and then they form a solid. And aqueous solutions are solutions that basically mix a substance in water, and then the substance was dissolved, right? So reactions, and I realize sometimes when I go back to my lectures, look at them, I realize that I didn't do a good job writing well, and maybe just if you couldn't read what I'm writing, just let me know. I'm just like rushing to finish everything, so I may fail to write well. Reactions that form a solid upon mixing 2 aqueous solutions. For instance, we have potassium iodide, that is aqueous, plus PbNO3 2 lead 2 nitrate, aqueous gives lead 2 iodide plus potassium nitrate. And you should be able to name these compounds and then write them. Can anyone tell me why I put aqueous for these but solid for this? So if I don't give you this, how would you know which ones are aqueous, which one is solid? Anyone? So any of you remember the solubility table that I gave you? That they were like so many ions? So if you look at those, and then the combination would be soluble, you put aqueous here. If not, if those two ions, for instance, lead and nitrate, if they are not soluble, they won't, dissolve in each other. So we put, or like rather, their combination wouldn't dissolve in water. So we put solid here. Is that clear? Just ask me anytime that you have a question. So by the same rationale that what I just said, so we call this a precipitation reaction because there is a solid formed. But if I write this reaction, potassium iodide and sodium chloride, if I write this, can anyone guess how would I predict if I have a precipitation reaction or not? Yes? Oh, no.
The lead diide,
Uh-huh.
that's a solid acid. So I assume that it's not a reaction.
Okay, so if you go to the solubility table, and then we see that though the combination of the anion and cation, they won't be soluble in water. If they are not soluble, we put solid here, and then we would be having a precipitation reaction. But, if I have this reaction, if I were to have a reaction, I would be having KCl plus NaI. Is this clear why? So you see here you have like K plus and I minus, cation, anion, right? Is this clear? This is how we were naming ionic compounds, right? They have a cation, they have an anion. This is the same thing here. We have Na plus, Cl minus. So if you want to have a reaction between two ionic compounds, usually the anion or cation of one, attached to the anion of the other, and this cation attached to the other anion. So if we were to have a precipitation reaction, we would be having like KCl plus NaI. Is that clear how we write this? And what you do after this, you go to your table 7.2. I'm going to write this here. And then you look up these ionic compounds. One of them is KCl. So if you go, you see that potassium, without any exception, forms soluble compounds in water, right? So KCl would be soluble. What about NaI? Again, so sodium iodide, contains Na plus, which is always soluble without any exceptions. So since both of them are soluble, they won't form any insoluble solid. They won't form any solid in the solution. Is that clear? No? So just remember the solubility table that I showed you. It's like table 7.2. If I give you two ionic compounds and I tell them, do they react with each other, or do they go through a precipitation reaction, what you do is that you separate the cation and anion in each one. So you say Ki is K plus and I minus. Is this clear? And then you do the same thing for NaCl. You say NaCl is Na plus Cl minus. Is this clear? And then you want to have a reaction, right? So if I have NaCl and Ki in the right side, it won't be a reaction. So in this category, I'm telling you, this is the rule. If they were to react with each other, the result would be KCl and NaI. Any questions so far? Is this clear? And you go to your solubility table, and then you think that, okay, NaI, is this soluble in water? And then you see, yes, it is, because anything that has Ni would be soluble. What about KCl? And then you say, okay, this has potassium, so for sure it's soluble. So would I see any solid here? Do I see any solid here? No. Okay, so here you won't be having reaction. I write no reaction. So to see whether or not you have a precipitation reaction or not, you go to your solubility table and then see if the upcoming compounds, or like if you were to have a precipitation reaction, you write those corresponding compounds and then see if basically these ones here, KCl, NaI, and then if they are insoluble, they form solid, and you see a precipitation reaction. Any questions about this? Yes.
Are we going to be expected to memorize the solubility table?
Yes. And the way to memorize it is by solving problems. And then when you do, problems, solve different problems, go through them, with time you memorize them. So that's why it's important that after this lecture, you go review your notes and then go to books examples and all other resources that you have in your book. Now that we are kind of done with this part, I'm going to talk to you about writing chemical equations for reactions. So, writing chemical equations for reactions in solution. Molecular, complete, ionic, and net ionic equations. So molecular equation is basically an equation that shows all your compounds as their neutral form that they participate in the reaction. So basically they are, or let me do this first, molecular equation. So molecular equation is an equation showing the complete neutral formulas for every compound in reaction. For instance, if you have silver nitrate plus sodium chloride, you get silver chloride plus potassium nitrate, NaNO3 aqueous. So you see complete formulas for each of your compounds. Basically the neutral version of those. Is this clear? Okay. The next one is complete ionic equations. So complete ionic equations shows your species in the solvent in the reaction as they actually are present. For instance, if you have silver nitrate, AgNO3, you don't actually in water see AgNO3. They dissociate to their ions. You see Na plus, Ag plus, and NO3 minus. And you see anions and cations that are dissolved in water. So basically in complete ionic equations, you see Ag plus NO3 minus plus Na plus Cl minus, and so on and so forth. So basically you see your ions, your species, as they are actually present in the solution, not their, neutral chemical formula. So, and then just interrupt me, ask any questions anytime. Feel free to ask me. So, I'm gonna just write with blue. Okay. Equations which show the reactants and products as they are actually present in solution. So for instance, the above equation here, it would be Ag plus aqueous plus NO3 minus aqueous plus Na plus aqueous plus Cl minus aqueous gives AgCl solid. You see that if we have like a solid here, AgCl, silver chloride, if we have that, it won't dissociate to its ion because it's not aqueous, it's solid. So we just write it as such, plus Na plus aqueous plus NO3 minus aqueous. And as you see here on the reactant side, I have Ag plus, and the other side I don't have it. So let me just erase this thing. Okay, so here you see, for instance, you have like NO3 minus on left side, you have NO3 here on right side, or you have like Na plus on left side, reactant side, and on product side. So you see, basically you have ions that they're not participating in the reaction. So we call them spectator ions. So we call these because they're not participating, they're watching the reaction basically. So this would be complete ionic equation. Any question about this? Yes.
So will you only mix the two together if they change physical state? Like the AgCl, for example? Or does that make sense?
So you can be given any equation and then you were asked that does this equation occurs or not. So you're welcome to mix anything in the laboratory, but the equation only happens if they form solid. If they're like aqueous, the reaction won't happen, so you just say no reaction. Yes?
How do you know which ion actually participate in the equation?
So the one that forms solid are the ones that are participating. So in this example, you have here AgCl, and then here you have Ag and Cl. So these are the ones that they are participating. Good questions, thank you. Yes?
I think what she meant to ask was, how do you know that those two are going to form such besides like the other ones?
So it's with your solubility table. If you go through your solubility table, if they are soluble, your two anion and cation. If they are soluble in water, you have an aqueous solution, so you won't be having solid. And in that case, if, for instance, imagine I gave you an example, and then here, this was aqueous too. So you won't be having reaction in first place. Does that make sense? Yes?
So how do you know to put Ag and Cl together rather than combine Ag with NO3 or Na?
So Ag, with Na3 is already our reactant. So if we would be having the same on the right side, we won't be having any reaction in first place, right? So it should be, it's kind of like I say, water converts to water. It can be like a physical change, but it won't be a reaction. So Ag, because it's a cation, it would form bonds with anion. So your options is basically whether NO3 minus, which is itself, which we won't worry about it because, as I said, we want to have a reaction. So the only anion remaining is just Cl minus.
Okay.
And then for that, Ag and Cl, you go to your solubility table, see, are they soluble or insoluble in water? If soluble, you won't be having reaction after checking the other one too, of course. So if you have this one is soluble, this one, if it's aqueous, you won't be having reaction. You just write no reaction as we did like above. Does that make sense?
Kind of.
Yeah. Yeah, after this, I post, I'm going to record some videos with more examples for anyone who is interested in watching them so that you have like ideas. Because in the class, I don't have much time, I cannot go through as much as examples as I want. But I'm going to post videos for you with more examples and explanations. So if you're interested, watch. I'm going to create another folder, like extra, problem lectures or something that distinguish them from the class lectures. Any other questions? Okay. So now I'm going to tell you about net ionic equations. So in net ionic equations, we just omit the spectator ions. So the ones that I highlighted above, or like circled them, because they're not participating in the reaction, we omit them and just write species that are actually participating in the reaction. So that would be net ionic equation. And the definition is, as what I just said, equations which show only the species that actually participate in the reaction. So for the above equation is Ag plus aqueous plus Cl minus aqueous, which gives HgCl solid. So it actually only shows you what is reacting with what and what is the outcome. Is this clear? For molecular equations, you just write the complete formulas of your ionic compounds. You write everything. For complete ionic equations, you dissociate them. So you just write whatever you actually see in your solution. For net ionic equations, you just write whatever that actually participates in the reaction and actually reacts. So if no question about this, I'm going to talk about two other forms of reactions. One of them acid-base reactions and the other gas evolution reactions. So we kind of talked about gas evolution reactions. Does anyone know how do we distinguish gas evolution reaction or what happens in them? In gas evolution reaction, if you remember, it's kind of like the baking soda and vinegar example, that there is a gas being produced, right, like carbon dioxide. And then in acid-base reaction, as the name suggests, we have an acid and a base, and then they react with each other. So maybe I write this with red rather. Acid, base, and gas evolution reactions. So I'm kind of emphasizing the definitions and all because I'm going to ask you in the exam, and then if you know them, it would be pretty straightforward for you to gain points, and then you should know them to be answered to solve problems as well, you know. Acid-base reactions. So in general, in acid-base reactions, you have like an acid and a base. They react with each other and then they produce water. So reactions that form water upon mixing of an acid and a base. I'm gonna write the gas evolution definition as well, so you have the definitions next to each other. Reactions that evolve a gas. Any questions? So you need, yes?
Does the acid-base reaction form water and the salt of the acid and base?
Yes, most of the time, yeah. And I'm going to write it momentarily. So you need to know these definitions because if I give you a reaction, you know, and I'm going to ask you in an exam that I give you like an acid and a base, and then first of all, you should know how to distinguish them. You already know acids. Can anyone tell me how would you recognize that you have an acid? Exactly. So if I give you, for instance, KOH, can anyone tell me what is the name of KOH? Yes, potassium hydroxide. So that is the base. And then I say I have like KOH plus HCl. And I give you the basically the right side of the equation, the product's blank. And I expect you to be able to write it. So this is how you know, based on the definition, that how to write and complete equation. So that's why, I'm emphasizing that in gas evolution reactions, you have like a gas being produced. In acid-base reactions, you have water. And then as we go on, you see that you have like more of these to remember. So, going back to acid base, and the other name for them is like basically acid base reactions are also called neutralization reactions. So you have HCl aqueous plus NaOH aqueous, and that gives water, we know as a fact I just mentioned based on the definition, that is liquid. Plus, so how you write this for acid-base reactions, you always have water, because in acids you have H plus, in bases, right? You say bases, right? In bases you have OH minus. So basically this was Na plus, this is H plus, Cl minus. So in acid-base reactions, H plus in acid reacts with OH minus in base, and it forms water, right? This is your definition. That acid-base, they generate water, right? And you know now why, because acids, and I can kind of write that here, that in general acids have like, sour taste. They have ability to dissolve metals. And they have tendency to produce hydrogen ion when they are in a solution. So tendency to form H plus ions in solution. A base, on the other hand, or like NaOH base in general, they have like bitter taste. They have like a slippery feel. Just right. And they have tendency to produce OH minus when dissolved. So I wrote them down, so if I tell you which one of the following is not a characteristic of an acid, and then I give you, like I tell like bitter taste, you know that, okay, this is a base. Any question about this so far? So we know acids generate H plus, bases generate OH minus. So when we have them in the solution, they will generate H2O, water. And this was the case for precipitation reactions, the case here too. You write your acid as H plus and the anion, and then your ionic compound as cation and anion. And then H plus reacts with OH minus, generates water, and then Na plus reacts with Cl minus, would be NaCl aqueous, which is salt. And as your friend mentioned, in acid-base reactions, we have water produced and an ionic compound that we call it salt. Any question about this? Are we good? Oops. Or anyone writing, or you're good? Can I scroll up? Okay. So now this is the first question that I'm asking you to answer, and this one has 1 point. Each question that I give you has 1 point unless I specify otherwise. So this one would be due at the beginning of next class, so just write the solution in advance. I encourage you, just don't do it like 10 minutes before the class, because I want you to go home, read the notes, go through the book, because I want you to learn and get good grades for your exam 4 and your final exam, okay? So study, and then while you're studying, answer this question, piece of paper, take a picture, email me, and get 1 point for your exam 3. And this is something that I forgot to mention. Even if you got 100 on your exam, I still give you 101, because I'm going to add all the grades out of 800. Yes?
So does this count towards our next exam or this?
So, in practice, it doesn't matter, because, both have 100, and I'm going to just add all the grades together. So, but I'm going to add it to your exam 3, so you'll be encouraged that, okay, now your exam 3 is going up, and now you can study for exam 4. But in practice, I'm adding all the grades, and then it would be out of 800. And as I said, this is extra grade, so if you think you don't need it, you don't have to, but I extremely encourage you to work with me, study, and, just solve it. So, it's write the complete ionic equation, or like complete ionic and net ionic equations for the above reaction. And as you see, the above reaction is HCl plus NaOH gives H2O plus NaCl. Are we good? Okay. If no questions, I'm going to talk about gas evolution reactions. So as we mentioned, gas evolution reactions are reactions that they produce a gas, for instance, carbon dioxide. But whether we mix 2 compounds and then we see carbon dioxide, or gas. I was just thinking about that great volcano example. So whether we mix compounds and then we see gas immediately, or we mix 2 compounds, they form an intermediate product, and then that one dissociates and produces carbon dioxide. So whether we directly see a gas, or first an intermediate is formed and then we see the gas. For instance, if we have like H2SO4 aqueous plus Li2S, Li2 S aqueous gives H2S gas plus Li2SO4 aqueous. So here we see the gas directly. So you see, we just see H2S. Or in another example, we have like HCl aqueous plus NaHCO3 aqueous gives H2CO3 aqueous plus NaCl. So you have hydrochloric acid, and then you have sodium bicarbonate, and then they form hydrogen carbonate and sodium chloride. So here, first they form So we call this, do you remember what we call this? I think I said it wrong now. Do you remember what do we call H2CO3? Anyone? So what type of compound it is? Acid, yes, we see hydrogen. Yes, yeah, I think I said it wrong when I was writing it. So this is hydrochloric acid, this is carbonic acid, because it has like oxy acid. It is an oxy acid. Anyway, so here, after we saw this one would dissociate to H2O and CO2. You see? You can kind of like see that you have like H2 with one O here would be H2O and then CO2 plus NaCl aqueous. And this is your gas. So here we see the formation of intermediate first. Forms intermediate product first.
So why would it not be CO3 instead of CO2? Like why did it leave
Because when you have like carbonic acid, and then basically when you have like gas evolution reaction, this is like the most stable form of compounds. When they want to dissociate for this specific reaction, it's like water and carbon dioxide. So you may be able to, go to the lab and, may be able, but these are like the most stable form of compounds. That's the reason when you have like carbonic acid, it dissociates to water and carbon dioxide. So it's kind of like the rule to remember,
So basically, I guess on the H2O, it would have one of the oxygens, so that would make the CO2.
Exactly. Exactly. Yeah. But the question that you're asking is like more fundamental question. You should study the orbitals, and then the things that we're going to go in the next chapters to why exactly the atoms would form. Why do we see CO2 but not CO3? It's kind of like more fundamental question. But for the sake of our lecture now, you just remember that this is the most stable version of the compound. And if you just study more advanced courses, you calculate, you have like, you can put the atoms in different configurations and calculate their energy. And usually the lowest energy is the most stable form of the compound. So in this case, would be CO2, not CO3.
Okay. Yeah. Thank you.
Of course. Yes, did you have a question? Yes.
It was kind of along the same lines of hers. It's just like a polyatomic ion, so it feels like when it's separated, you can see.
Yeah. So, for the sake of our course, if you go, and you have a table that lists like all the, compounds and then what, a specific, and I can give you the name of the table, basically table. So you have like table 7.3 for like acid and bases, and then for gas evolution reaction, you have table 7.4 that, for instance, is written that if you have like carbonates, you see carbon dioxide. If you have sulfites and bisulfites, you see like SO2, sulfur dioxide, or ammonia. If you have like ammonium hydroxide, you see, ammonia. So kind of like it gives you what is being generated. So for the sake of this course, you can just remember these, and then when you go through the examples, you kind of like know what gases are being formed. So any question about this, anything that we talked about? So for next session, you just answer the question that I gave you, and I'm going to give you more questions as we go along. And if you answer all of them, study well, you can both get a good grade on exam 4 and then improve your exam 3 grades. Yes, I was hearing some of it. the ones that I posted, you just like without them. I'm going to add them later. Yeah, don't worry. Yes. So what did you get on test two? Yes, I saw first. So you will be having 75 total. And then if you do the extra points that I'm giving, you know, your exam 3 grade would increase. I think I give you so many so you can increase it even.
I just didn't know if you were gonna put the extra credit on that.
Yes,
Replace
yes.
your grade too.
Yeah, for the replacement, I include the extra credit.
Awesome, thanks.
Of course.
Just to be clear, we are emailing.
Yes.
Okay, just saying.
Yeah.
Thank you.
Of course. Yes, yes, I will post it. Probably it takes like 1 hour or 2 to upload, but. What's that? Yes, I post it on my website. So yeah. Or like sooner, maybe.
What's the example of a net ionic equation?
So in the complete ionic equation, you write all the ions that you have, Na plus, Cl minus, you write all of them. For net ionic, you just write the ions that actually participate in the reaction. For instance, you know, you have like Ag plus Cl minus, it's not AgCl solid. Hold like 1 minute. So I can just like get out of it. Just give me 1 minute. If I see that you tried and then you write the solution and I have the feeling that you tried your best and it's just not helping with the solution what I need, yeah, I give you the first one.
Okay, perfect. And you don't care if we use a measurement for that?
No.
Yeah.
No, it doesn't. Yeah. So I have like just like 12:30 to 1:30 after each class. But I mean, if you guys want me, I can just do more. But
Okay, well, that works for me. I can come in at one of those times. I just wanted to ask a couple questions about the test only because I came into a couple of your office hours last week and I went to 2 or 3 of the tutoring sessions. So I spent quite a bit of time preparing and studying, and usually I do well on the tests, and I just was a little frustrated because I ended up getting 65, and so I just want to figure out what I can do in addition to the extra 5 questions to prepare. So
yeah, I appreciate
I'll
it.
stop by at some point.
Thank you. Of course.